Welcome viewers. Today we are discussing about the most important chapter of physics. That one is kinematics. Now here we start that the word kinematics is derived from the word kinemia. Word kinemia meaning motion. You know that motion, whatever the motion, but those motions which do not require any force. You mean the branch of physics which deal with the objects, motion of objects without any reference of the force. You mean they do not require any kind of force. They do not require any kind of agent would cause them motion. It means we call it kinematics. Here the students are confused. They mostly ask, how is it possible that one object is moving and it does not require any kind of motion? Yeah, but it's the truth. Then how? Whenever you see any fruit, as apple is it falling from the tree, whether it required any kind of force? No, it means it's kinematics. Kinematics defines such kind of forces which do not require any kind of agent. So it has mechanics and dynamics, two types. One is dealing with branch of physics. When the objects are in dynamics, we call it mechanics. And dynamics word is derived or taken from the word dynamic, meaning power. You mean whenever whenever you can say uh, things which causes the motion and how they affect the motion. This means we are talking about dynamics. But in the kinematics, two quantities are mostly used. One is scalar, second is vector. Mostly physics students are aware about these two words, scalar and vectors, but sometimes they are being confused. One is that scalar. Why scalar? In a scalar, these are the physical quantities, but in these physical quantities only required magnitude. They only have a magnitude. But what is missing? They have missing a direction. They don't have a direction. They have only magnitude. So they are called scalar quantities, and they are related with kinematics, the most important one. Now you can easily add, subtract, multiply, all these kind of arithmetic methods you can take. But in these scalar quantities, examples you can mostly have heard common these words: mass, time, distance, speed, work, and energy, temperature, mostly the charge. All these are the examples of the scalar quantities. Mostly other types are also examples are present, but here are the fewer ones which mostly we concerned in the physics. Now all these one, the mass, time, distance, speed, and number of the students has seen that on the clock, on the watch, they have experienced very well that time is no direction. Now what's then vector quantities? The vector quantities are those physical quantities which are completely specified by their magnitude, and what else? That means they have a direction which is missing in the scalar quantities. Now both are known. Wherever the magnitude and direction are present, it means they are vector quantities. Vector quantities mean the simply the examples mostly come in our mind is displacement, velocity, acceleration, force, weight, torque, momentum, etc. All these are the vector quantities. Why vector quantities? Whenever you will see the apple is falling, it means it's falling in any direction. If anything will have a direction, it means it's a vector quantities. Now, now where is the speed? Speed is the distance covered by a body moving. In a unit time, we called it its speed. It's a scalar quantity, no doubt. But what about the formula? speed is equal distance upon time. You mean you can shortly can or precisely you can write the formula v is equal s upon t, and the mostly the unit, what is the unit, SI unit of the speed? It is meter per second, or you can write like meter per second minus 1 means this one is a simple one. Now, two types of the speed mostly we have heard. One is uniform, variable, and average. These are the simple types. But the most two types uniform speed we have heard if a body is moving or covering equal distance in equal interval of time. It means 2 minutes, 2 kilometers. Again and again, it means the body is seems in the uniform speed. What about then the variable one? If the body is moving does not cover equal distance in equal interval of time, it means its speed is variable, means it is moving in a different speed. Then how to average speed? What it means? If we divide distance covered by a body by unit time, by a time interval, then we can easily find the average speed. Total distance upon total time is so common, but mostly asked how to find the average speed. Formula same one, no doubt. There is not any difference in it. Now, mostly the common word here it comes is velocity. What is velocity? The distance covered by a body in a particular direction is called velocity. Oh, that's the velocity. Velocity, displacement upon time. Both are look the same one. V is equal S upon T or V is equal D upon D. But here is a displacement. Little bit resemblance or the similarity of the formula easily to remember. It's a unit of velocity is meter per second. Now here it comes the types. Oh, types of the velocity. Types of the velocity. One is uniform velocity. Oh, this word is so familiar. When speed and direction of a motion of body do not change, they are the same one. They are not being changed. It means the velocity is to be uniform. Okay. Then what about the variable velocity? Variable velocity of the body changes of either its speed changes or a direction. Oh, it means it's a variable velocity. Now again, average velocity. Simply, you can easily find v is equal d upon t. Then so easily. Okay, now acceleration. Acceleration? Oh, the rate of change of velocity is called acceleration. Whenever the velocity change is acceleration. Whenever the velocity is not changing same, no, then what about the acceleration? Good question. It is denoted by a, it's a vector quantity, and its formula is acceleration is equal change of velocity upon time. A is equal vf minus vi upon t, or you can say delta v upon delta t. This arrow shows that it has some direction. Vector quantity. SI unit, SI unit of acceleration is meter per second square. Types of acceleration. Positive acceleration or negative acceleration? Oh, uniform acceleration. Might be variable or zero acceleration, but the average acceleration until remaining. Now first one is positive acceleration. What is positive acceleration? If the body of velocity of the body increases continuously, it means the acceleration is being increased, then the acceleration is said to be positive. It means our acceleration again and again being increased. Now then what is negative acceleration? If the velocity of the body decreases, it's not increasing continuously, then the acceleration is said to be negative. And this negative acceleration is also called deceleration or retardation. It means acceleration is not increasing, it is decreasing. Then what about the uniform acceleration? If the velocity of a body changes, okay, by equal amount in equal interval, it means both are equally just changing, it means then it's a uniform acceleration. Variable acceleration. Oh, the rate of change of velocity is variable, then the acceleration is said to be variable. It means the velocity is being completely changing and changing and changing. Then what about the zero acceleration? Mostly students confuse in it. If a body moves with uniform velocity, then it is a zero acceleration. It means the velocity is not being changed, it's same, start throughout, then zero acceleration. You cannot say it's positive, negative, it's a zero acceleration. Now finding the average acceleration. Okay, so simple. The formula, as you can easily see, acceleration is equal to delta Vf minus Vi upon T, or delta V upon delta T. First equation of motion. So much important one in every exam, whether it is concerned A level, O level, but this one is so important one everywhere. MCAT, MDCAT, wherever you will go, you will see this one. Suppose a body is moving, initial velocity, you know Vi, and undergo some changes in it, then you know the T. Final velocity Vf, then what it will be? The time T is equal Vf minus Vi. So you can say unit time in the velocity Vf minus Vi upon T. So simply you can say A is equal to Vf minus Vi upon T, or A will divide or multiplied with At is equal Vf minus Vi is equal At. So simply we have made a first equation of motion, that one is Vf is equal Vi plus At. It's an important one and mostly used in every kind of numerical concerned with equations of motions. Now the second equation of motions, suppose the body start with the initial velocity Vi and travels with a uniform acceleration, you know, A. Then what happens? It means some time of t. It will definitely take some time. It means t. The distance covered by body in this time is s. You distance s. Oh, final velocity becomes vf. Then easily you can find the average velocity. Already know vf plus vi upon t. Then whenever the distance come, you know the formula. Average velocity into time. You mean v or t. Oh, then how average velocity will be? S is equal to vf plus vi upon 2 multiplied t. Then first equation of motion, oh, vf is equal vi plus at, easily remember to every student. But what about this one? vs is equal to vi plus vi plus ast upon 2 into t. S is equal to vi plus at into t. Oh, vi plus vi, it means 2 vi. Okay, then what? If we have a 2 vi plus at upon 2 into t, so easily you can write by in the two ways, 2 vit upon 2 plus at square upon 2. Simply cancel 2. Then what will you will get? S is equal to vit plus half at square, or 1 upon 2 at square. This is the second equation of motion. Students, you have to remember this equation. Without it, no numerical, no problem. Everything will be difficult. So, second equation says, do remember me, S is equal vit plus 1 upon 2 at square. Oh, now the third equation of the motion is awaiting. What it says? Is there any difference? No. Samely, the body will again start with initial velocity vi. Then what? It will travel some uniform acceleration, again a. Then what? For a period of time t. It will cover some distance. Okay, distance covered by body, we will say s. Now the first equation of motion again came, because it is an important one in equations. Vf is equal vi plus at. Now first of all we have to take squaring on both sides. Vf square plus is equal vi plus at whole square. Everyone knows who is a student of the math, but mostly every student knows that we have to open the square formula. It will be vf square is equal vi square plus 2 vi at plus a square t square. Then what about the VF? Okay, again VF square is equal VI square plus 2A VIAT plus 1 2 upon 2 AT squared commonly 2. The equation will be S is equal VIT plus half AT squared. Simply everyone knows that 2 is a common one and it will be easily cancelled. So 2as is equal to vf square minus vi square. This one is the third equation of motion. Okay, motion under gravity. Now what it is? Motion under gravity means the change in velocity. Now this change in velocity is due to the attraction of the earth. Whenever the attraction of earth is concerned, it means the acceleration is due to gravity, or the gravity we will are simply know it is SI unit is G, or denoted by G, meter per second is square. And this G is taken as 9.8, or somewhere you will see is 10, just rounding off, it will be 10 meter per second square. So this is the common one, and formula is same, vf is equal vi plus gt, or same. Okay, one numerical we can easily see. Okay, the velocity of a motor car moving along a road increases from 10 meter per second to 50 meter per second in 8 seconds. Here is time given, here is velocity is given. Then what we have to find? We have to find average acceleration. Okay, easy, you know very well about the formula. Okay, what is then? It is a is equal to vf minus vi upon t. Vf is 50. Okay, final one, minus 10 upon 8. 8 is the second. 50 minus 10 is 40. 40 divided by 8, it will be easy. You can say that a is equal 5 meter per second. That's the answer. Okay, so easily find. Okay, one more. I know students, you are so intelligent and you can easily correct this example of a problem. A car is moving with a velocity of 36 kilometer per hour. Here is a kilometer. Okay, on a straight road. On the application of the brakes, then what happens if the application of the brakes? It comes to rest after covering a distance of 10 meter. Then what we have to calculate? We have to calculate deceleration, you mean. Okay, now first of all you will see the velocity. We have to convert in meter per second, kilometer 1000, hours, you mean 3600 seconds, then multiply with 36 and divide, then we will get 10 meter per second. Okay, then final velocity is 0, distance given 10. We have to find the acceleration. What is deceleration? Formula 2as is equal vf square minus vi square. Just substitute the values. 2a multiply 10, that one is the distance covered by body. 0. Okay, final velocity. Okay, then what about the initial? Is 10. 10 square is 100. Okay, whenever we will say 10 multiplied to 20, 20 will come and divide the 100, it will be minus 5 meter per second. Okay, here we covers the kinematics in one shoot and with examples. Now first, second, third equations. Now do it, students. Please like and subscribe the channel and keep hard working.